This question is about a fast food restaurant that uses an automated filling machine to pour its soft drinks. The machine has a different setting for small, medium, and large. According to the machine's manufacturer, when the large setting is chosen, the amount of liquid L dispensed by the machine follows a normal distribution with mean 27 ounces and standard deviation 0.08 ounces. So L for large. Okay, and I have my mean for my L as 27 ounces. My sigma for my L is 0.8 ounces. Okay, and then it continues on to tell you for the amount of the liquid M dispensed follows a normal distribution as well with mean 17 ounces and standard deviation 0.05. I got that info here. And then it tells us to test the manufacturer's claim. The restaurant manager measures the amount of liquid in each 20 cups filled using the large setting and 25 cups filled using the medium setting. So it doesn't say an SRS, but we would have to assume that they did an SRS for this to be, legit. So that's a concerning thing about this question, although I didn't make this question up, so your textbook has it. I wonder if in the copy paste I missed it. But regardless, we're just going to assume they are SRSs because we can't do it if it's not randomly sampled. Okay, so both of our sample sizes are here. For the large, 20 cups. For the medium, 25. All right, so estimate, so it already gives you the let part. Let the XL and XM be the blah, blah, blah difference. They already told you what it is. The difference in sample means of amount of liquid under the two settings. You do not need to rewrite that. Good enough. Okay. All right, and so estimate the probability that the difference in sample means is within 0.25 ounces of the true difference of means. First of all, the true difference in means is 10 ounces. So it has to be within 0.25 of that. So 0.25 less than that, 0.25 more than that. So basically this, it's asking for 9.75 to 10.5. And it's the sample mean for large minus sample mean for the medium sampling distribution. We're looking for this to be between this and this. How do I know that? It says here, estimate the probability that the difference in the sample means, this is the difference in the sample means, is within 0.25 of the true difference. These are considered the true difference, the population difference. It's was talked about in chapter 7.1 in lesson 7.1 about the word true, implying the true population. All right, and so let's continue. We're finding the mu of the mean of large minus the mean of medium. That's 27 minus 17 again, 10 ounces. I already did that up here just to get this, but it doesn't matter. I just wanted to show the work there too. That's how I got the 10 ounces. 10% condition. Okay, here's my large population has to be over 200 and my medium population size has to be over 250. We would need to assume this restaurant has more than 200 large and 250 medium cups. Okay, we would have to assume that to use, I seem to have forgotten on all of these, to use sigma formula. Okay, and then here's our sigma formula. I would again urge you to do this first, then this, and then add them up and then square root, and you get 0.2049. Since both populations are approximately normal, so is the sampling distributions of the difference in means. Okay, and so draw your normal curve. You have your mu of the difference of the means is equal to 10 ounces. The sigma of the difference of means is 0.2049 ounces. Here's 10 in the middle, 9.75, 10.5. This is the sampling distribution of the difference of means. And so we're looking for the probability of the difference of means being between 9.75 and 10.25. That's an in-between question. So no 1E99 or negative 1E99. So it's between these two numbers, 10.2049. We get 0.777. I'm sorry, too many sevens. 0.776. The probability that the difference in sample means of the large and medium settings of the liquid dispenser is within 0.25 ounces of the true difference in means is 0.776. Whew, mouthful. All right, this one we're going to skip right now because you're going to do this one on your own a little bit. Let's look at the NFL versus NBA question. It's a little different than the one before, so I want to make sure I cover this one. It's very similar, but, you know, just a little different. So the National Football League, NFL, the distribution of age skewed to the right. So the distribution of the players' ages are skewed to the right. So 26.2 years is the average, and the standard deviation is 3.24 years. The NBA, on the other hand, is also skewed to the right, actually. It's not different, but it's a little lower. It looks like the mean age is 25.8, and then the standard deviation is 4.24. So more variable than the NFL. The NFL ages are closer together at around 26.2 than it is for the NBA, but the NBA age is lower, the average age. Okay, so independent random samples. Thankfully, this one said random sample. 20 players in each team. So basically, NFLs and oof. It's a good thing I went over it. This is NBA. Okay. So 20 for each. All right. And then the means are, and the standard deviation is here, and the mean and the standard deviation for the NBA is there. And I believe they gave you let X bar NFL represent the sample mean of age of NFL players, and let X bar NBA represent the sample mean of NBA players. Find the mean of the sampling distribution of blah. So this is not asking for probability right now. It's just asking for the mean. So the mean is just subtracting of the means, which is 0.04 years. Just the difference of the means is just subtracting. Right. Okay. And then calculate and interpret the standard deviation of the sampling distribution. Verify that the 10% condition is met. All right, so the 10% condition, we're checking for NFL, 10 times 20. NFL players, the number of NFL players must be greater than or equal to 20. And the population size for NBA was also, sorry, not 20, 200. And then the NBA also has to be greater than or equal to 200. It's safe to assume there are more than 200 players within each league. I mean, you don't know if you can't say it's safe to assume, the best bet would be to say we need to assume. We need to assume instead of safe to assume. But I do know that there's a lot of players in each league. You're talking about the all the teams, and then the backup players and all sorts of players. Anyway, so yeah, 200 is not a hard number to reach when it comes to the leagues. And then so since to use the sigma formula, of course I forgot that, to use sigma formula. Alrighty, and here's the sigma formula, and we find that it is 0.11932, and it says interpret it. The difference of the means of the ages of NFL and NBA players will typically vary from 0.4 years, which is the mean, by about 1.1932 years. And that's interpreting your sigma. All right, next one. Is the shape of the sampling distribution approximately normal? So here it says it's skewed to the right and skewed to the right for the populations. Since it's skewed to the right and skewed to the right here, we must check for the central limit theorem. So unfortunately, both of the central limit theorems don't pass for this one. So the sampling distribution is not approximately normal. Since both population distributions are skewed to the right, we need to check for central limit theorem. And little n of NFL is greater than or equal to 30. Is it? 20 is not greater than or equal to 30. No. And same with here. You know, it'd probably be best to put this question mark because we're verifying that. And so, nope, 20 is not greater than or equal to 30. The sample sizes are too small. Therefore, the sampling distribution of the difference in the sample means of the age of NFL and NBA players is not approximately normal. So notice we did not try to solve any of the rest. We failed. We cannot calculate this probability. Okay, and they didn't even ask you for that either. Notice the question is just asking you to find mean, did it, and just asking you to find standard deviation, assuming the condition is met, did it, and they're asking, elaborate on this, would you? So, did that. All right, the one before this is a very normal, that one was a weird one, so go back to the last problem before on the last page. Pause the video here and attempt the problem and, you know, check your work and so on and so forth. The same old stuff. All right. Take care.